I finally did it. I tried one of these LED stripes with single programmable LEDs, and what you see here are 4 green dots, and what they do is they are like H-top. So as soon as I put load on the system, like resizing Windows or something like this, you will see the CPU load goes up, and as does the light bar. And what I can do now is that I start memcpy. This is a in-memory database on Raspberry Pi. And I will do this SQL query, select count star, and this SQL query will occupy all CPU cores for a while until the query over multiple million rows is finished. How did I do this? To look at the code, we have 2 components put together here. One thing is the NeoPixel board, the NeoPixel library, which helps me to program this LED matrix. So I have basically just 3 pins directly wired to the LED pins, namely the 5 volt, the ground, and the 5 volt, the ground, and GPIO 18, which will put the signal. So you have, if we look in the close-up, you have 3 pins. We have the ground on the top, we have the 5 volt power supply on the bottom, and in the middle there's the signal pin. So what the library does is I initialize to use GPIO 18. I have a total pixel of 144, and I created a helper function called fill ratio. Look, if I scroll, you will see the CPU usage going up. So I have this helper function fill ratio, which will take an X position and the width of a bar and a stride. So I can also, for instance, cut these into pieces and put them like this and this and this and this. And so I have all this 4 CPU cores underneath each other. I compare everything that is inside the bar will get a color, and everything outside the bar will get black. And these pixels are calculated from green to red. So the red is the more ratio we have, the redder it will get, the pixel, and the less we have, the greener the pixel will be. And then the second part is just opening ports stat, and then counting the difference in the CPU stats. So it is the user time, the nice time, and the system time divided by the user time plus the nice time plus the system time plus the idle time. And by this I get a pretty nice CPU usage bar. Yes, this is stored in ratio, and then this ratio is rendered on the stripe. And in the last comment I will do a pixels.show. So there are 2 modes. There's a auto write mode and a auto write false mode. And in the auto write false mode I fill the buffer first, and then this pixels.show will export all the pixels. So it's like a shift register. If you see the LEDs are shift registers, so you can cut them at any point that you want. And every single LED has these 3 pins, in and out. So the ground and 5V will only go in. And then there's a data input and a data output pin. And the data output pin from one LED goes into the data input pin from the next LED. And what you finally achieve with this is a shift register. Like you write a color into this, and the data will be sent there. And then if the LED itself is addressed, then it will set its own color, and otherwise it will decrement the LED ID and send the command to the next LED. So there's not a CPU, but a small controller in this LED that will parse the messages from the data bus and put it forward, so they are like daisy chained, or how you want to call it. And yeah, this way you say like please turn on LED 5, and this will pass the message please turn on LED 4. This will pass the message please turn on LED 3, turn on 2, turn on 1, turn on 0, and then this LED will turn on. And now for the summary, I will scroll again, and there you will see the CPU usage goes up as soon as I scroll